Hey there, welcome back. This is another episode of A Software Engineer Learning to Hack Live. Thanks so much for tuning in. This episode is all about an introduction to networking. So we're going to be walking through one of TryHackMe's rooms where you can learn the introduction to networking. I'm going to be upfront and say I'm not going to go over all of it. From my training and experience, I have learned and already have a knowledge of a lot of this material. So I think we're going to go mostly over the substantial things, the tangible, the tools and things like that. But I'll briefly cover some of the networking topics that are important to hacking. Just like my previous videos, I am running a Kali Linux VM where I'm going to be doing all of my hacking challenges. This may be boring, bear with me. I'm honestly going through this for the first time. Some of this I know, yes, but if you're learning this for the first time, this is one of the few types of videos where I might be ahead of you, but it's not because I have any type of hacking training. It's just that there's going to be this overlap between understanding software or the IT world. Because to write software or to build IT solutions, you need to understand a lot of these aspects. But if you've gone through any type of technical degree through university, then you most likely have had this training, and this will be easy for you too. Let's look at the introductory networking course. You can see a couple of the topics that are going to look through some of the foundations of networking, which is the OSI model and the TCPIP model. Again, I'm not going to deeply kind of focus on a lot of it because I already got this through college and reinforced through experience. There's an acronym, or not an acronym, a way to remember the OSI model, basically just how data is transferred throughout the computer, all the layers, so that it splits up all the different functions as data needs to get manipulated. And you can read this on your own time. It's definitely good to know. FTP, I think, communicates with, is it the application? Which transport layer protocol we best do to transmit a live video? We're talking UDP there. The reason why UDP is the best for transport is because there's no connection oriented, so it can just send the packets, and there's no extra overhead about whether or not it was received and sending over missed packets, because you're transmitting live videos. So that's precious time that you're losing. So you want to make sure that when you're transmitting live data, audio, video, anything else, you've got UDP as your protocol, so that you can make sure that you're not missing that live aspect. And if you've ever watched live video and you see little areas of the screen sort of look pixelated, it's basically because those packets weren't received. So the monitor is typically just not updating properly because it doesn't have data. So all right, 2 more questions before we're done with this section, then we'll continue on. Networking tools is really what I want to focus on. The FTP protocol. All right, so it wants us to research. Let's look that up. Which layer? FTP OSI layer. Application layer. That's what I thought. I thought it was an application. Did I get the number wrong? Application is 6. Oh, application is 7. That's why I got that wrong. I thought application was 6. All right, yeah, that's an application. All right, we are done with the OSI model. Okay, so once you understand the different levels of the OSI model, it's important to understand that as data gets passed down from each level, you're going to have basically the data being modified. There's going to be basically split up, and then it's going to be encapsulated in its own way. You can read all the information. You can see here there's a little diagram of data that gets added on. So every layer is going to add their data till you have all the bits at the very end right here. And in the case of a data link, it also adds a trailer that aids in the submission or the receiving. Basically telling it that it's ending. The data's ending. How would you refer to data at layer 2 of the encapsulation process? Those are called frames. So each part of the data at its different level has a different name. All right, now the TCPIP model is basically the heart of the internet, because that's what everything runs off of, pretty much TCPIP. It's almost like its own model inside of the OSI model. They're related, but not exactly the same. Here's a good little representation of the relationship, where TCPIP covers everything in the OSI model, but they just, honestly, in my opinion, simplify it. Because you have everything at the network interface level, then everything to the internet, to the transport area section, and then go up to the application. So all right, it's all based off of connection based communication. So some buzzwords to understand. I mean, obviously TCP/IP standing for Transmission Control Protocol, and IP standing for Internet Protocol. Definitely look those up. Make sure you're familiar with those terms, as well as sort of what they look like in practice. An example of all this would be a client-server communication. So you have your synchronize from the client to the server, client responding with their unsynchronized, as well as like an acknowledgement. You'll see ACK a lot and things like that. And then finally, the client sending a packet that basically says the acknowledgement, confirming the connection has been set up. And then at that point, data can be transmitted, and you make sure, that's when you have that reliability of you won't have any packets that are going to be lost. What is a short name for acknowledgement segment? Got the ACK. ACK. Okay, now we're getting to some fun stuff. I probably edited out a lot of what I just went through, so you won't see everything I just said. Okay, so being able to put this into practice, at least for me, is super helpful in learning the basics of networking. There's a tool called Wireshark, and it basically allows you to watch packets that get transmitted over a network, and you could see all the data that forms like the different headers and the areas that when you see the diagrams, it can only help you so much. So let's see what they do with Wireshark. There is a actual Pcap file, and I've used Wireshark in school, but I've never actually worked with it within my software engineering career, because typically there's network people. I work at a pretty large company, and so I get to focus on my direct development of the products, and there are teams dedicated to analyzing the network, and I only focus on, I guess you could say, the local network of the solutions that I develop. So we're going to download Wireshark. I'm not going to make you watch this, so I will just pause this and I'll fast forward to when I have it installed. Okay, so being a Kali Linux novice, didn't realize that Wireshark was already built in. Makes a lot of sense though. So we're going to go back to the room and download the file. Just gonna save into the downloads. All right, that's done. Let's go back. Okay, so we're going to want to open the Pcap file. So just navigate to wherever you stored that. Okay. Let's do it like a side by side. Whoops. There we go. And there we go. Okay. So, there's a couple pieces of data here, captured data. Okay, so this is basically two different types of data that was sent over this particular captured set. So you can listen over a particular network interface and basically capture the data that gets sent over. So this can be used for informational purposes, for analyzing a network, perhaps for the performance of a network. It could also be used for malicious purposes because you can listen over a network and potentially see message in plain text. It's less relevant today. Most information is being sent encrypted, and so it's all gonna just look like nothing readable. But here and there is something that you could see. So we have some data, and you can click on any particular data that was captured, and you can actually look at some of these different layers, if you remember. So you have the actual frame from the data link, and then you have the Ethernet from the network, or from the frame freeing the physical, I believe, the Ethernet, and then that's the data link, and then you have the network layer, the transport layer, and then at this point you're into the application layer because that's the HTTP. But you can see here, I mean, you might recognize that you gotta have a GET request, and that's running over HTTP like 1.1. You see there's a host, a user agent, accept. And then of course you can see the data as you expand it. I'm sort of going ahead on a whim. All right, so they're basically saying you can look at all the stuff that I just described. Click on the second capture packet. So by all means, if you want to dive into the Wireshark room, you can go ahead. I'll definitely cover that in a future video, but for now I'm going to stick within the scope of this current video. But yeah, we're only dipping our toes into Wireshark. It is heavily dense. All right, now they want us to click on the second one. So now you're going to see all the same types of pieces of data. However, you notice you have the frame, you have the Ethernet, you have the IP. All are going to be the same, but then what's changed is now we have DNS, a protocol that's running over UDP. So you can see the different data about the UDP. That's the port it's running on from the source to destination, how long it is. They have a checksum and everything because that's this layer checks for errors, and they use a checksum for that. And then you have the actual DNS query. So this was a DNS for google.com. So it was wanting to do a DNS lookup for google.com. Destination is this particular IP right here. So 172, I think that sounds like a DNS server. All right, they want us to answer the following questions about this second piece of data. Oh. Yeah, those are MAC addresses. I knew that. Yeah, the first half of the MAC address basically is specific to the manufacturer of network interfaces. So that is going to be fixed, which is why you see HUAE underscore and then the second half of the MAC address. That's going to be the specific address of that manufacturer device. So didn't hit me right away. All right, I think we're going to hit ping. Then we're going to probably stop and make this into a two-parter, because there's just so much foundational information in this. Ping is huge though. I'm not going to read all of this. I've used ping plenty of times. Whenever you're trying to just see if there's a server that is up or that you have network connectivity to, ping is great because you can ping an IP address, you can ping a URL as you see, you ping google.com. We'll even just do that for just for the sake of there you go. All right, so what you see right here is that you have 64 bytes every single time it's pinging. It's gonna ping until I tell it to stop. That's the default behavior. And then you see some other data here. Right off the bat, the obvious one is time. So how long it took to receive a response from google.com for those 64 bytes. You see the IP address, so it was able to translate the URL to the IP address. And then another important information is time to live, which is 117. Basically means how long is that going to request allowed to stay out there without it coming back, receiving, and then determining that it was like a failure. So that'll just go on forever until I Control-C out of that. And then at the end, you can basically determine from that data right here we're seeing, you know, am I able to connect to it? Typically, my experience has shown it's either all received or not received. So it's either 0 or 100 in my case, but there's certainly cases where you have inconsistent network connectivity and you may lose some packets. I just haven't hit that yet. What is the IP address? All right, they want us to ping this. Okay, found the IP. That is ping in a nutshell. I think that section doesn't do it justice. I think ping is also really helpful. I'm guessing it could be really helpful in the hacker's toolkit because say you've gained access to a network, but your goal is to gain access to a server in a particular network. Depending on the network configuration and how complicated it is, I could see it be beneficial to be able to ping and see, have I gotten to a point where I've got access to the server yet, or do I need to keep basically hopping? Okay, trace route. I'm gonna stop here and I'm gonna create another video. There's just so much information and I'm probably gonna have to edit out a lot of what I went through and just keep like the core network stuff. But definitely learn some of this on your own time. Hopefully I can just sort of make this relatable and, if anything, give you the motivation to come learn it alongside me. Even though some of it's a review, I admit, I'm still definitely learning a lot. And hopefully while it's boring, it's kind of like learning the scales on an instrument, right? You learn the scales, and then once you understand that and it becomes intuitive to you, it helps you when actually learning how to hack. So learning networks is learning how to hack. because you have to get into a network. So remember that this is all for ethical purposes, and by no means do I condone red hat hacking. This will all be white hat and ethical hacking. And I hope that you take some things away from this that help make this world more secure. Hope you have a wonderful day or evening, and I will catch you in part 2 where we finish up the intro to networking and get to the good stuff of actual hacking. So see you there.